Hello and thanks for joining. Today we're going to work on Singleton design pattern with the Rust. And if you're not familiar with the Singleton based on Gang of 4 design pattern is a creational pattern that makes sure the class has only one instance, one provider, a global point of access to it, and that's it. So let's just jump into the implementation. We're going to start from the very basic simple implementation in Rust, and we're just going to expand it and make it thread safe and generic down the road. So if you're ready, let's start it. So the very first thing, I'm just going to put them in different module just to separate them. First thing, we're just going to define a struct and Singleton, and the Singleton has in here, which is for now is just going to be U32, and this is going to represent the object that we're going to create. So what we need to do, we want this Singleton to be static and accessible in throughout our application. So let's just do that. And we're going to define it as Singleton. And over here, we're going to say Singleton with new. And just for the sake of this instance, we're just going to say this Singleton is going to be 42 for creation it. So now we need to implement it. So Singleton, implement Singleton, we need to have one new function. So let's just find it, public fn new. We're going to get a value, which is U32, and return self, and the Singleton is going to be just in here of value. So nothing too special. And after that, we need to have define one function for getting instance, and just gonna mutate value. It's because we want to mutate over this value, or define it as mutable, and it is going to return a mutable U32, and we're going to define let instance equals sorry, this should be self dot here, and we're returning instance, of course mutable instance. So we just have to define it here and just return instance. Okay. Well, so this is the skeleton of the Singleton for now. What we need to do, just take a look at this part for new. We're assigning the static, and whenever we were assigning the statics in Rust requires us to have a constant function. So what we need to do is just have to define const to make this function const, and that should be it for now. So let's just write a couple of tests for it. And okay, if you look at it here, the Singleton and as you can see, we need to define this static mutable if we want to access it through mutable reference. And I think that should be it. I'm just going to make some modification to allow that code. Cargo test, and it's working perfect. So in this test we use instant1 as mutable u32, use the instance from the singleton, and in instance 2 we just use the singleton directly through unsafe. And the reason we need to use unsafe is because we are using a mutable static structure. It forces us to use unsafe, and we're gonna have to deal with it also ourselves. So as you can see, this is not a singleton that you won't like to use it in the production. So what should we do? Well, for second part, let me just copy this part and go with module step 2. So in here, we want to find out a way, or come up with a way to initialize the inner value of the singleton, initializing the singleton here. So how can we do that? There's one simple way, could be just can define it as option u32, and can just ignore this. Going down here, you can just ignore the value and assign the value to none. Well, this way we just told to our singleton that we are going to assign the value to you later, and the way we're assigning the value to this part could be that with function of like init, and maybe mutable self and value of u32 for now. The way we're going to work with it is that you can say like self just inner equals sum. Well, now the application or the singleton requires us to actually assign a value or initialize a value after it's being used. So we need to have some modification here. So basically, first of all, we should change it to option, and option 32 and singleton. Okay. Now, over here, what we need to do, we need to assign the value to it. So I'll use just, for instance, instance 1. Dereferencing it equals sum42. Okay, let's see if it's working or not. And voila, it's working. So what we did, we separate this initialization part from here from definition, and now it requires us to actually go and create it manually. But this might not be a very practical way. So how can we improve it? If we refer back to definition of singleton, we need to initialize our object once, and then it's been called. So how can we do this? A very simple way in Rust is to use once structure. So how can we use it? Well, for start, we should use std sync once, and we also need to state that we need a public static once, which is the type of once, and it's going to be once. Well, now instead of calling this init function over here, we need to assign the init ourselves. Now, how do we do that? Well, let's get back to our singleton here. We can define one function as init. It's going to be a function which returns us u32. In our new function, we take this init to the function u32, and over here we just assign it to our singleton. Now, when we need to get an instance from our object, what we can do is we can come over here and say once dot call once, and it's going to be closure, and inside this closure we can call our init function, get the value of it, assign it to our singleton, and then return it. So how do we do that? Well, it's very simple. Let's init equals self, that's init. Let's value is going to be init, and we're just going to call the function, and we need to call unsafe, and not this unsafe, we're going to call singleton dot inner, it's going to be sum, and after that we can just call self and return it. So we don't need to use option here, just going to use u32, but down here we need to state that this is as mutable, and then we need to unwrap it, because in here over here is returning a mutable, a reference mutable to option u32, but we need a reference mutable to u32. Now back to our new function, and just to pass a closure. In this example, I'm just going to call 0 on it. Now, to make sure that this part of the function is going to be run once and only once, okay, now let's go to our test. We're going to use a singleton instance, so it's going to be super.singleton get instance. Both of them return u32. We're ensuring that the value is both of them are 0 at first, because we pass 0 here, and then we're going to assign one of them with 42, and then we check that both of them are going to change to 42. And now let's just test it. As you can see, initializing singleton value has been called once, and it has been accessed twice. Okay, so now seems to be our problem solved, except we really don't want to have our singleton being initialized at first, because over here we're setting that it is a singleton, and we pass an instance of singleton to our singleton here, and maybe we don't want to do that. We wanted to initialize it later. So what do we do? Okay, let's just copy this section as singleton as step 4. Okay, one thing we can do is just use std mem MaybeUninit, and this is indicating that it might be initialized later. So how do we use it? Well, we need to wrap our singleton inside MaybeUninit, and we need to call MaybeUninit on init. Okay, now we have a workaround the lazy initialization. Well, one thing we need to fix is to how do we want to initialize the singleton value. Well, let's go with the public static init, and it is going to be a function that it's going to return u32. And we need to assign it here. One way we can go around this is to just go with option, and for now just assign it to none and assign it later when we need it. So come down here, what we need to do, we don't need to actually call new, and we can actually take this instance creation out of our singleton implementation. Now, this is going to be a public fn instant, and it's going to return us a static mutable u32. Now, back to our call once. We're going to use onSafe, and we're going to check whether our init has been assigned before or not. So if that none equals init, just going to return or run panic. Okay. Now, what we need to do is that instead of self, we're going to say unsafe init. And over here, we need to unwrap it, and it's going to return a function which is returning u32, and then we just call this function. And here's the things which get interesting. So over here, we need to create a singleton. Singleton is a singleton. The in-here value is value, and I think we can actually get rid of this option here. And over the singleton, we need to call the write function, and we're just going to write singleton. Now, definitely we do not need to use init here, so we can get rid of it. And I think it's safe to actually remove these print functions. So now we need to change how it's being accessed. So it's going to be unsafe. It's going to be mutable singleton, but assume init mutable dot in-here. We can actually get rid of this unsafe here because we're just accessing it, we're just reading it, we're not assigning, so it's safe to remove. Also same thing. Okay, looks good to me. Now let's bring the test here. So the first step is that we need to use onSafe to use a super init, and over here and it should be static, right? Let me just yes, it should be mutable. So now I think it should be okay. Well, yeah, we should wrap it around on safe, because now it's mutable. And this one should be safe. And I think it's safe to say it's good for now. Cargo test. Voila. Okay. Well, it's somehow working now. Still, it's far from completed. So, what's the next step? Well, we can make sure that our singleton is thread safe and we can access it through one thread each time, and we can use Mutex over that. So how do we do that? Okay, now let's move to the part 5 and make our singleton implementation thread safe. Let's wrap around our U32 in the Mutex over here, and also in a singleton add Mutex new with a value. We also need to add SCD sync Mutex over here, and that's it. So getting to the test, what we're doing over here now, we're creating 2 instances, and in order to get the values, we need to call lock on the in-ear and unwrap it. This would be totally up to us how we're going to handle this errors of the locks. Over here, we're checking the instance 1 and instance 2. Should be 42, and we're getting immutable over the in-ear, and we're assigning it to 24 from instance 1 and checking it on instance 2, and vice versa. So I just run a test, and it's working. Now, what's the next step? We can make this implementation generic. So okay, now we want to make these implementations generic. So the first thing, just gonna copy paste it over here. Now the first thing that we can do, just go over here and change this U32 to the generic type of T. But as you can see, we cannot do that. Well, there are crates out there that we can actually work around these problems, but we're going to use vanilla Rust. So what we can do right now is to use macros and macro rules. So the way we can do it is to just call macro rules and call it singleton, and simply move everything inside. What we need to do, we need to define a type. So $T represented as a type, and we are going to place U32 with a type. So same thing over here, $T. Okay. And next one, we need to have a way to set this init. So we're going to say $E as expression. We can remove this option and just say that this is going to be a function returning T. And that's it. There's going to be a little bit problem here. If we call in our test we call Singleton U32 and the expression would be just 42, and another Singleton for type U64 and 42 for this one. As you can see, there's going to be a lot of error here. The reason is that the second time we're calling this macro, it's going to return the same names for Singleton once init, the type of Singleton, struct, and instance. How we can get around this? In the nightly Rust, there's a concat ident that we can actually concat these idents with a type that it is passed to, or we can do another thing, can just wrap everything in another module. It's going to be a public module, and over here we need to assign a name for it. So I'm going to add a $name representing ident and wrap everything inside this module. So now this should fix it. So we also need to import this usings. Okay, we can get rid of this unsafe part. Just assign it to the init, get the value, and set it. Okay. Well, now we don't need to have this statics as public. We can just get rid of them. One thing we need to add here is to add a mechanism or function. We need to add a function in order to access the in-year value from the instance. So it's going to implement Singleton. This is going to be public function in-year, going to be mutable self. This is going to return us mutable mutex of type T, and it's going to return mutable self.in-year. In our test, the this should be in here. Okay, in our test, this is the same test as before. What we're doing here, you're creating 3 singleton with 3 different types, 3 different names, and the initializers. Second test, which we added here, this one is going to get the 3 instances of them, check their values. This one is going to assign to the float, and this one is going to assign to the U32, and these have different instantiation, so none of them should have overlapping. Same thing, just checking the value, and also we can drop one of the instances and the other instances can still work. And that's it. Let's just run the test to be sure. Voila. So if you have any question, post it in the comments. If you like this video, don't forget to leave a like and subscribe, and I will see you in the next one.